The use of a 10/2 cable to the outdoor disconnect with a whip is generally considered correct. However, a connector should always be used at the knockout where cables pass through the back of the disconnect. This omission is a violation of the National Electrical Code. The 14/2 UF cable is not rated for direct burial and should not have been run through the same knockout as the 10/2 cable. It should have been run separately in conduit or flex. Furthermore, the 14/2 cable is not rated for 30 amps and should not have been installed on the line terminals of the disconnect. There are no specific tap rules that apply in this particular situation. However, it is generally not acceptable to tap off a 30 amp circuit with a smaller gauge wire. The wiring as described is not up to code and poses a safety hazard. Therefore, the following corrections should be made. Firstly, install a connector in the knockout where the cables pass through the back of the disconnect. Secondly, run the 14/2 UF cable separately in conduit or flex. Thirdly, replace the 14/2 cable on the line terminals of the disconnect with the 10/2 cable. When wiring electrical systems, it's crucial to adhere to the National Electrical Code, or NEC, and local electrical codes to ensure safety and prevent hazards. One common area where violations occur is in the wiring of air conditioning systems. Let's break down some potential issues. Firstly, the importance of using the correct cable type. For outdoor disconnects, using a cable such as 10/2 is a typical choice for smaller air conditioning units, but the specific size depends on the ampacity requirements of the equipment. It's imperative to calculate the load and select a cable with an appropriate ampacity rating as per NEC Table 310.15. Secondly, the significance of proper connections. Where cables enter or exit enclosures, such as disconnects, connectors are essential. These connectors serve multiple purposes. 1. They mechanically secure the cable to the enclosure. 2. They provide strain relief, preventing stress on the conductors inside. 3. They protect the cable from abrasion against the metal edges of the knockout, or CO. Omitting a connector is a code violation and creates a potential safety hazard. Thirdly, understanding UF cable. UF, or underground feeder, cable is designed for direct burial applications. However, even UF cable has limitations. It should not be installed in a manner that exposes it to physical damage, and it must be protected where it enters a building or enclosure. Running UF cable through the same knockout as another cable can create a crowded and potentially damaging situation, especially if the knockout is not properly sized for multiple cables. Fourthly, overcurrent protection and conductor sizing. This is perhaps one of the most critical aspects of electrical safety. The overcurrent protection device, such as a circuit breaker, is designed to protect the conductors from overheating and causing a fire. The size of the conductor must be matched to the rating of the overcurrent device. For example, a 14 American wire gauge, or AUG, copper conductor is typically rated for 15 amps, while a 12 AWG copper conductor is typically rated for 20 amps, and a 10 AWG copper conductor is typically rated for 30 amps, according to NEC Table 310.16. Installing a 14/2 cable, which is rated for 15 amps, on a 30 amp circuit breaker is a serious code violation and creates a significant fire hazard. If an overload occurs, the 14/2 cable could overheat before the 30 amp breaker trips, potentially leading to a fire. Fifthly, tap rules. Tap rules allow for the use of smaller conductors to be tapped off of larger conductors under specific conditions. These rules are outlined in NEC Section 240.21 and require careful consideration of factors such as the length of the tap, the ampacity of the tap conductors, and the overcurrent protection provided. In the scenario described, the installation does not appear to meet the requirements of the tap rules, as the 14/2 cable is not properly protected by an overcurrent device. Let's elaborate on conductor ampacity and appropriate uses. Conductor ampacity refers to the maximum current, in amps, that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. This rating is crucial in ensuring the safe and reliable operation of electrical systems. The NEC provides tables, such as Table 310.16, that lists the ampacities of various conductors based on their size, insulation type, and insulation conditions. The ampacity of a conductor is affected by several factors, including firstly, the size of the conductor. Larger conductors have a greater cross-sectional area and can therefore carry more current without overheating. Secondly, the insulation type. Different insulation materials have different temperature ratings. Conductors with higher temperature-rated insulation can operate at higher ampacities. Thirdly, the ambient temperature. Higher ambient temperatures reduce the ampacity of a conductor. Fourthly, the number of conductors in a raceway or cable. When multiple conductors are installed in close proximity, they generate heat, which reduces their ampacity. The NEC requires that the ampacity of conductors be derated when there are more than 3 current-carrying conductors in a raceway or cable. UF cable is designed for underground applications but has limitations. It is typically used for direct burial installations, meaning it can be buried directly in the earth without requiring additional protection. However, UF cable must still be installed in accordance with the NEC. UF cable should be buried at the proper depth, as specified in NEC section 300.5 to protect it from physical damage. It should also be protected where it enters a building or enclosure. UF cable should not be used in locations where it is subject to physical damage, such as in exposed locations or where it could be run over by vehicles. When running a UF cable through a knockout, it is important to use a connector that is specifically designed for a UF cable. These connectors provide a watertight seal to prevent moisture from entering the enclosure. They also protect the cable from abrasion against the edges of the knockout. Let's also discuss troubleshooting wiring errors. Incorrect wiring can lead to a variety of problems, including electrical shocks, fires, and equipment damage. It is important to troubleshoot wiring errors carefully and systematically to identify and correct the problem. Here are some steps to follow when troubleshooting wiring errors. Firstly, turn off the power to the circuit. This is the most important safety precaution. Before working on any electrical circuit, always turn off the power at the circuit breaker or fuse box. Secondly, visually inspect the wiring. Look for any obvious signs of damage, such as frayed wires, loose connections, or burned insulation. Thirdly, use a multimeter to test the wiring. A multimeter can be used to measure voltage, current, and resistance. This can help you identify problems such as open circuits, short circuits, and ground faults. Fourthly, check the continuity of the wiring. Continuity testing verifies that a complete circuit exists and that there are no breaks in the wiring. Fifthly, verify the polarity of the wiring. Proper polarity is essential for the safe and reliable operation of electrical equipment. Sixthly, consult the NEC and local electrical codes. These codes provide detailed requirements for electrical installations. Make sure that your wiring complies with all applicable codes. To avoid wiring errors, plan your work carefully. Before starting any electrical project, take the time to plan your work carefully. This includes determining the proper size and type of wire to use, selecting the appropriate overcurrent protection device, and ensuring that all connections are made properly. Following safe work practices is a must. When working on electrical circuits, always follow safe work practices. This includes wearing appropriate personal protective equipment such as safety glasses and gloves, and using insulated tools. Don't take shortcuts. Electrical work is not the place to take shortcuts. Always follow the NEC and local electrical codes. If you are not comfortable working on electrical circuits, hire a qualified electrician. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. If you encounter wiring that appears incorrect or unsafe, it's crucial to address the issue promptly. The first step is to de-energize the circuit by turning off the corresponding breaker at the electrical panel. This ensures your safety while you investigate the wiring. Next, carefully document the existing wiring configuration. Take pictures or draw a diagram to help you remember how the wires are connected. This will be helpful when you make corrections. Once you've documented the wiring, you can begin to make corrections. Start by addressing the most obvious issues, such as missing connectors or improperly sized conductors. When installing connectors, make sure they're properly sized for the cable being used and that they are securely tightened. When replacing conductors, use the correct size and type of wire as specified by the NEC. Pay attention to the insulation rating of the wire, as well as its ampacity. After making corrections, double-check your work to ensure that everything is wired correctly. Use a multimeter to verify that there are no short circuits or ground faults. Also, check the polarity of the wiring to ensure that it is correct. Once you are satisfied that the wiring is safe and correct, you can re-energize the circuit. Turn the breaker back on and test the equipment to make sure it is working properly. If you are not comfortable performing these tasks yourself, it is best to hire a qualified electrician to do the work for you. Electrical work can be dangerous, and it is important to take all necessary precautions to ensure your safety. In summary, several key points need to be remembered for electrical safety. Proper wiring to disconnects requires correct cable type and size, secured with appropriate connectors. UF cable must be installed according to NEC guidelines, avoiding shed knockouts without proper fittings. Overcurrent protection must match conductor ampacity to prevent overheating and fire hazards. Tap rules must be strictly followed when tapping smaller conductors off larger ones. Regular inspections and troubleshooting are essential to identify and correct wiring errors. Always prioritize safety by de-energizing circuits, using appropriate tools and personal protective equipment, and consulting with qualified electricians when needed. By adhering to these practices, you can ensure the safety and reliability of electrical systems. In any electrical installation, always consult the latest edition of the NEC and local electrical codes to ensure compliance. This will help you avoid code violations and create a safe and reliable electrical system.